Hey, and welcome back to Split Second Science. Today, we will be explaining the basics of black holes, but I certainly will cover the more complex stuff about them in the not-too-distant future. Effectively, a black hole is a massive curvature in space-time. When an object gets compressed down small enough, it becomes a black hole. However, larger black holes can be less dense than others. This means that you would get ripped apart if you were to enter a 2 or 3 solar mass black hole, but would be fine entering a 1 billion solar mass black hole, though the radiation and stuff would probably get you at some point. To collapse Earth into a black hole, you need to collapse it into an area equal to the size of a US penny. However, it wouldn't have any effect. Our moon would continue to orbit that tiny black hole, since it still has the same mass as the former Earth. To collapse our sun, you need to shrink it down to 3 kilometers. The radius required for a black hole to form from a certain object is called the object's Schwarzschild radius. A black hole is so dense, not even light can escape. However, that is not why they appear black. They appear black because once light gets so distorted, it redshifts into invisibility. And no, they don't suck you in. Orbit a black hole as you wish. And if you free fall inward, just turn on your rocket thrusters to escape. However, let's say you free fall into a stellar mass black hole. What would happen? Well, there is a barrier called the event horizon. Once you cross it, nothing can escape, and you are isolated from the rest of the universe. Forever. The strange thing is that it distorts space-time so much that once you cross the event horizon, every single direction leads back into the black hole. To an outside observer, as you approach the event horizon, you would begin to redshift and slow down until you would eventually stop. Just as you hit the event horizon, you'd be in suspended animation, frozen forever. But to you, time would go by fine. This happens in any black hole. However, in a stellar mass black hole, tidal forces will rip your body apart. The gravitational force inside the event horizon will be millions of times stronger on your head than your feet. You will get ripped apart in a process called spaghettification, and after some time, you'd be a hot stream of plasma, 1 atom wide. There are 3 sizes of black holes: stellar mass, intermediate mass, and supermassive. Stellar mass black holes form when a star explodes in a supernova. Sometimes, the core of the star will just collapse into a neutron star. In other times, it'll go all the way down to a black hole. Intermediate and supermassive black holes occur when stellar mass black holes merge together over and over. Supermassive black holes are located at the center of every galaxy, millions or sometimes billions of solar masses. Stellar mass black holes rarely exceed 100 solar masses. An intermediate mass black hole can be multiple hundreds or even thousands of solar masses. So, that's the end of this video. If you have any science or history topics you'd like me to cover, leave them down below. This is Split Second Science, signing off.